When certain things happen in the browser, mainly when the user takes action, such as clicking on something, this triggers what's called an event. And in our JavaScript code, we can register functions to be executed when certain events occur. What you see here is a mostly complete list of all the events that get triggered in the browser. First we have the load event, which is actually the only event here which is not triggered by some user action. The load event is triggered when the elements of the page have finished loading and so are ready to be used. They're ready to be inspected and manipulated in our JavaScript code. This event is quite important because if in your code you try and access some DOM element, you're going to get an error if you attempt to access an element before it's ready, before it's loaded. What we usually do then is put all of our code in a function which we then register to execute when the load event is triggered. Thus we ensure that our code only runs when the document is ready. The canonical way to write this in jQuery is to get a jQuery object wrapping the document object itself and then invoking on that jQuery object the ready method. The ready method takes one argument, a function, and this is the function that executes when the load event then triggers on our document. So going back to our page template, this is what it should now look like. All of the code we want to execute should be in the function which gets triggered upon the load event. Going back to the list of events, the unload event, somewhat confusingly, is really not the converse of the load event. It's actually what gets triggered when the user, say, closes a browser tab or closes the browser window, or when they try and switch away from a tab or away from a window. You may have come across a few sites that spring a pop-up on you when you try and close them. For example, Gmail does this because in Gmail they don't want you to accidentally close the tab if you're in the middle of writing an email. So they register a function to run upon the unload event, and that function is bringing up a pop-up that asks you, are you really sure you want to close this browser tab? The next 5 events, blur, change, focus, select, and submit, all relate to forms. The first of these, blur, gets triggered when an element loses focus. Like say if you're typing in an input box and you click somewhere else, well that triggers the blur event because that input box lost keyboard focus. The change event is triggered when an input element of a form has its value changed. Like say if a checkbox gets checked or unchecked, or if a radio button is clicked, etc. The focus event is the opposite of blur. It gets triggered when an element gains focus rather than loses focus. The select event is triggered when, in a text box, the user selects some amount of text by, say, clicking and dragging. And the submit event is triggered when a form is about to be submitted. And notice I say before, because in the handler function for a submit event, your code can decide to actually cancel the submission of the form. And this is useful because sometimes you want to check the inputs to validate them, see if the user has entered sensible values, and if not, you can give them an error message saying, hey, you failed to fill out this text box or something like that. Next, we have a couple of events related to the window itself, that is when you resize your browser window or when you scroll the tab up and down. And then we have keyboard events for when the user hits keyboard keys. There's key press, which is a full down and up motion on a key. But then there's also key down, which gets triggered immediately when the user pushes the key down before they even release it. And then there's key up, which only triggers when the user actually lifts up the key. Now, of course, when the user presses a keyboard key, you want in these events to have the information of, well, which key is it? And so that information, of course, is included in the event. So in the handler function, we can have that information. Lastly here, but very importantly, we also have mouse events, such as when the user clicks on something, or when they double-click on something, or the mouse down event for when they just press the mouse button down, mouse up for when they release the mouse button up, mouse move just for when they move the mouse over certain elements on the page, and the mouse over event gets triggered on an element when the cursor moves over the element, and the mouse out event is triggered on that element when the cursor leaves the element, goes outside of its bounding box. Like, for example, if you have an image on the page and the user drags their cursor from not on the image to then being inside the image, that will trigger the mouse over event, and then when they drag the cursor outside of the image, that'll trigger the mouse out event. And of course, very important to all of these mouse events, as well as a number of other events, is the question, well, which element of the page did we click on? Which element did we move the mouse over, etc.? And that information is included in the event itself. So the handler functions which we register to execute when these events trigger, they get that information of, well, what thing was clicked on, what keyboard button was pushed, what form element received focus or lost focus, etc. So again, very importantly, every event which fires has a so-called target. And what actually happens in an abstract sense in the browser is that the event then propagates from the top of the hierarchy, from the root of the DOM, the document object, all the way down to that target element. And then once it reaches there, it actually then propagates back up in a second phase called the bubbling phase. When the event is filtering down from the top down to the target, that's called the capture phase. And then on the way back up, that's called the bubble phase, bubbling. Together, though, this very abstract notion of events traveling from the root down to a target and then back up again, that's called propagation. And the point of this propagation is that as an event propagates from each element down the chain and then back up, on each stop it checks to see if there is a handler registered for that event on any of those elements. So in fact, say when we register a function to be executed when the click event is triggered, we don't register it for the whole page, we register it for some specific element. So say that we have a document as pictured here, we have an image inside a div, inside the body tag, inside the HTML tag, inside a document. Well, if the user then clicks on this image, that will create a click event, which will then propagate from the top, from the document object, down to image, and then back up. And for each element, the browser checks to see if a click handler has been registered on that element. So in this example, imagine that the div element here has a click handler attached to it. So in the capture phase, that handler will then get executed, and then the event will continue on. It will go down to the image tag, and then it'll bubble back up. Now the question is the same handler going to get triggered in both the capture phase and the bubble phase? And the answer is no. Actually, when you register a handler, you specify whether you want it to trigger in the capture phase or the bubble. You have to make a choice. It's either one or the other, which is a good thing because there's really no reason to ever want it to trigger in both phases. Come to think of it, it's really kind of odd that we have both of these phases to begin with. Why do we have both a capture phase and a bubble phase? Why don't we just have events propagate in one direction and call it good? Well, that's originally the way it was, except the Netscape Navigator browser had the capture phase and Internet Explorer and other browsers had a bubble phase. But then the committee that created the DOM standard decided to compromise and just have browsers implement both. So there's both a capture phase and then a bubble phase. In my experience, I've basically never used the capture phase. The bubbling phase makes the most sense as far as I can tell. So I always register handlers to trigger in the bubble phase, not the capture phase. And as far as I can tell, that's pretty much what everyone else does too. So now, how do you actually register a function for an event? The DOM method for this is called AddEventListener. It's a method of DOM elements themselves. So here we use getElementById to grab an actual individual element, and then on that element we invoke AddEventListener. We specify that we want to listen for the click event in the first argument, just a string. The second argument is the handler function itself. Notice that it takes one parameter, which here I have called event. You can name the parameter anything you want, but it makes most sense to call it event because that is what's passed to that parameter, is an object representing the event itself. Like say in a keyboard event, that event object will contain information about what key is pressed. In a mouse event, like a click event, it'll have information about what element was clicked and which mouse button was used, etc. And finally, the third argument to AddEventListener is simply a boolean specifying whether to trigger this handler in the capture phase or not. True means to run in the capture phase rather than the bubble phase. False means to run in the bubble phase, not the capture phase. So here I've specified false because, as I said, and as far as I can tell, the bubble phase is what you want really all the time. Now, there's a problem with AddEventListener, and that is that it's not supported in Internet Explorer. In Internet Explorer, there's a different mechanism for registering event handlers. Conveniently, though, jQuery offers its own mechanism for registering handlers that looks quite similar to AddEventListener. The on method will register a handler on all of the elements in a jQuery object. So here we have a jQuery object with just a single element, the element with the ID Fred, and we're registering a click handler as specified by the first argument to on, and then the second argument is the handler function itself. Notice there is no third argument. There's no argument specifying whether to execute this in the capture phase or the bubble phase. Well, jQuery simply doesn't let you choose. It always specifies the bubble phase. And this is for two reasons. One, as I said, it's pretty much the phase you want to use in all cases I've ever encountered. And second, Internet Explorer historically has not supported the capture phase. So if we want to write code that works in all browsers, we need to just use the bubble phase. Now, when in a handler function you wish to access the target of the event, well, there's a property on the event object will give you access to that. A problem, though, is that the events generated in some browsers differ from the events generated in other browsers. The event objects for key presses or the event objects for mouse clicks don't look exactly the same, say, in Internet Explorer as they do in Firefox. jQuery, though, very nicely normalizes these event objects to be consistent in both browsers, so that's some of the magic jQuery is doing for us. Now, in these event objects that get passed to our handlers, you have a couple important properties, including target and current target, and it's important to distinguish between them. Say again that we have our document where we have an image inside a div, and we add a click handler to the div, and then in the document, in the page, we click on the image. Even though we clicked on the image, which has no click handler itself, thanks to propagation, the click handler on the div is going to execute. And when it does, in the event object, the target property will refer to the thing which was actually clicked, the image, whereas the current target property will refer to the element whose attached handler is being executed. So looking at this in practice, again we're attaching a click handler to the element with ID Fred, and in the handler we're using event.currentTarget, which will refer to the element with ID Fred itself. So we're taking that element, wrapping it in a jQuery object, and invoking the hide method, effectively then hiding that element. So what this code effectively means is if the user clicks on Fred itself or on anything contained within Fred, that event will bubble up to Fred, invoke this handler, and hide the Fred element itself. Now, it turns out that accessing the current target is something we do often enough that the designers of jQuery decided, hey, we'll make that a bit more convenient. And so jQuery arranges things such that your handler function gets invoked as a method of the current target element object itself. So the reserved word this in the function becomes effectively an alias of current target. So the code in this example does the same thing. If anyone clicks on Fred itself or anything contained within Fred, then the Fred element is going to get hidden. Now the question is, what's the difference if instead of current target we use just target? Well, the target property in a click event always refers to the element which was actually clicked. So assuming the element Fred has other elements within it, if we click any one of those things and this handler gets invoked, then what's being hidden is not Fred, but that thing which was actually clicked. Now, as a further convenience, jQuery includes more succinct methods for registering handlers on the more commonly used event types, such as click. So there is a click method which takes simply a single function argument, which is the handler to register for the click event on the set of elements in the jQuery object. Now that we have event handlers, we can actually do some interesting things in our pages. So going back to our template, if we then fill it in with some actual code, well, notice in the body we've added two p tags, the first given an ID of TED, and then in the script, inside the document ready function, we're adding our actual code, starting with the declaration of a variable TED, to which we assign a jQuery object containing the element with the ID TED. And then we register a click handler on this jQuery object, and in this handler we'll simply take the current target, TED itself, the thing to which we're attaching the handler, wrap it in a jQuery object, and then modify its CSS color property via the CSS method, and we're going to make the color red. The color property, remember, is the color of the text, not the background, so it's just the text. So if I then load up this page, this is what I'll see. And then if I click on the first paragraph, the lorem ipsum, its text will then turn red. Now, as I mentioned, the event objects which are passed to the parameter of these event handling functions, they contain important information such as what is the target of the event, what key was pressed in a keyboard event, what mouse button was clicked in a click event, what are the coordinates precisely of where the mouse was clicked, that sort of thing. The precise details differ from one kind of event to another. Mouse events are not exactly the same as keyboard events. What all events have in common, though, are these two methods, prevent default and stop propagation. The stop propagation method is fairly self-explanatory. If you invoke it on the event, then after that handler finishes executing, the event will stop propagating. It won't continue on up the chain. What the prevent default method does, unsurprisingly, is prevent the default action from occurring with an event. Some events have an associated default action, such as, for example, when you click on a link. Well, normally when you click on a link, what's supposed to happen is that the browser will then navigate to the URL of the link. Well, sometimes we don't want that to happen. So if we register a click handler on a link, and then in the handler we invoke the prevent default method on the event object, that will prevent the default action. It will stop the browser from navigating to the URL in the link. The last thing to understand about events is very important, and that is that they are not processed concurrently. So if you trigger a bunch of events in the browser, those events and all the handlers that they trigger will be executed in order of occurrence without any overlapping. In other words, events in the browser always run in a single thread. On the upside, this means that you don't have to worry about concurrent data access the way you do in a multi-threaded context. You're effectively guaranteed that in the course of a handler function, nothing else is going to be touching the objects in the code or the elements on the page. On the downside, this lack of concurrency, this lack of multi-threading, means that you do have to be careful to make sure your event handlers don't run too long. Because say if you have a click handler which takes a full second to process, well, that's a full second in which the user can't interact with the page. Any other action the user takes that triggers an event is going to get blocked until those preceding events finish processing. So the general rule in the browser is to make sure that your handlers never take more than a fraction of a second to process.